It is July 4th, 1054, and in the sky a new star has just appeared. It will remain visible to the naked eye for 23 days and at night for 20 months. Throughout the history of humanity, by studying ancient texts, we find barely half a dozen of these appearances. But it is likely that a much greater number of these new stars were observed without ever being recorded on paper. And in the end, no one knows how many myths and legends the appearance of these new stars may have given rise to. Our ancestors who witnessed this phenomenon may have seen it as a premonition, the anger of the gods, or the birth of a son. In fact, it was its death, the swan song of a giant star, a supernova. An extremely rare event. On average, 2 such stars explode per century in the Milky Way. And since many of them are hidden from us by clouds of dust, when you're looking for this type of star, you mostly spend your time not finding any. The last time we were able to observe one in our galaxy was before the invention of the telescope. Luckily, space is vast, and occasionally these appear in distant galaxy images. Suddenly, a light source, absent from all previous photos and as bright as all the stars in its galaxy combined, appears, only to disappear soon after. Today, the traces of the supernova observed in 1054 are still visible in the sky with our modern telescopes. Here is what remains of it, the Crab Nebula, in the middle of which no longer sits a star that has now disappeared, and which has left behind a structure made up of streams of stellar matter ejected by the explosion and still surging through space. A millennium later, at velocities of several thousand kilometers, yes. Stars are not eternal, which is definitely very good news because their death means the birth of many other things. A star doesn't just emit light, it's also a factory that transforms matter. Because when they explode, supernovas almost completely fill in the coolest chart in the universe. Because it contains the 94 blocks that allow us to make just about all the material things in the universe. All the atoms we find here require very special conditions to be forged. As the universe cooled after the Big Bang, it allowed us to check off 3 boxes, but the rest of the elements had to wait to be made. To pass at least once through the heart or the outskirts of stars. That's where almost the entire cosmic alphabet was forged. But there remains a shadow on the picture in the form of several small holes here and there. The grid is incomplete as a few fragile blocks like boron, beryllium or lithium barely withstand the star's blazing furnace where they almost invariably transform into other elements. These elements are found in our enzymes and hormones, and without the existence of whom? Those atoms were almost all formed in the great cold of space. From other atoms that were transformed after being struck by particles speeding through interstellar space. And even so, the picture is still not complete, because we still have the problem of quantities. Because while supernovas do check almost all the boxes, they often don't fill them enough to explain the quantities of certain atoms we find in nature. Many rare elements are produced during these explosions in tiny quantities such as silver, gold, or iodine, which is vital to us, and in the absence of which. To explain the proportions of certain elements, we have to turn to a very rare event of a completely different nature, the collision of 2 neutron stars. A devastating tragedy that also somewhere indirectly involves supernovas. Because to form these strange stars, barely 10 kilometers in diameter and yet heavier than our Sun, first, a giant star must end its life as a supernova before leaving behind a tiny star of this kind. And when 2 of them meet, the violence of their collision will produce a black hole. All while synthesizing on its own the equivalent of about 10 Earths in gold mass, as well as uranium, thorium, platinum, silver, or iodine. All these elements will be ejected at tremendous speeds before spreading out into space. One day maybe, to end up around my finger. Because this ring was crafted by a jeweler working with gold, brought up from the depths of the earth by miners, extracting a metal concentrated by the geological activity of a planet formed from just a tiny part of an interstellar gas cloud, a cloud enriched with heavy elements. Produced by the successive lives and deaths of giant stars, and above all, by the collision of 2 neutron stars that have now disappeared, but whose precious residues, such as gold and almost all of the IOL, can still be found. In short, you see the picture, it's now complete. Everything is there. And basically, from that, you can make anything and everything. You, me, a stone, the earth, or a starfish. From the inanimate to the living, from the simplest to the most extraordinary, everything is actually made of this ordinary matter. Think of something, and as long as it exists, well, it's made of it. By the way, if you could extract yourself with tweezers, atom by atom, you would end up with a small pile of fine atomic dust that was never alive, but that once was you. For an average human being, we could thus recover about 45.5 kilograms of oxygen, 13 of carbon, 6.5 of hydrogen, 2.2 kilograms of nitrogen, 1 of calcium, 700 grams of phosphorus, 130 grams of sulfur and potassium. And we could keep adding to this shopping list for a long time. The thing to remember is that if you took away any one of these elements from you, from me, these small, isolated piles, sold at market price, would be worth about 2,000 euros, which isn't much. If we take into account that, from our point of view, these atoms are priceless, at least when they are arranged to make you, to make me. The problem is, if you mix all that together, at no point would you get you or me. The blocks are arranged in a specific way, which is where the complexity begins. Because even if we now have all the letters, which are the basis of the alphabet, of nature, we still need to be able to provide these 94 blocks with the right conditions so they can combine. Because even though in the furnace of stars some can transform into others, the affinities between the letters have nothing to say. It's way too hot there for the blocks to bond. But in the cold of space, the first words, molecules will be able to start forming in the filaments of dead stars that are cooling down, as well as in interstellar gas clouds. The temperature is low enough for some of these letters to eventually form water molecules. Carbon monoxide, methane, ammonia, alcohols, and even sugar. Or even formic acid, a compound that ants synthesize on Earth to mark their trails. In the interstellar medium, nearly 200 different molecules have been identified, and most of them are organic, meaning that, like us, they are carbon-based. Such as ethyl formate, a molecule responsible for the characteristic smell of rum and, in part, the taste of raspberries. Through the play of associations, guided by chance and affinities, the letters come together to form longer and longer words, giving matter a new language. Because, in groups, atoms behave differently than they do individually. By combining, they acquire properties they didn't have before when taken alone. Pure sodium is one of the most unstable elements there is. Throwing it into water could make you regret being born. Chlorine, however, is lethal to all. Yet both of them are highly valued and are essential to life. They make up salt, sodium chloride. Sodium hydrogen, pure hydrogen is a terrible fuel and oxygen promotes combustion. Together in space, they bond to form water. Once on Earth, the atoms, grouped together under milder and also more varied conditions of pressure and temperature, begin to build increasingly complex molecules. With oxygen, silicon, iron, and magnesium, you can already make a large part of all the rocks that surround you. There is a record of all known molecular species. They contain nearly 150 million entries, and this number grows by 4,000 each day. Almost all of these discoveries come from living organisms with whom the language of nature seems to become almost limitless. A simple protein can be made up of hundreds of atoms, all grouped together in a long chain called a carbon chain. This block here, carbon, known by its little name C, is the keystone of all living things. By easily bonding with other atoms, including itself, it allows the construction of molecular chains that are longer and more complex, containing thousands, millions, or even billions of atoms. Like in a double helix DNA molecule, a giant structure that can contain as many atoms as there are stars in our galaxy. But perhaps the most extraordinary thing isn't just the number of atoms it contains, but the fact that with this structure, life has devised a way, without us knowing originally exactly how, so that the molecules produced by the alphabet start writing novels. Because the appearance of life from matter is a new story that begins. That of a set of molecules capable of structuring themselves into now immense sentences, of copying themselves, replicating and reproducing, with perhaps a little more meaning and also more fragility. Because these DNA molecules, from which living beings write and copy their history, are easily vulnerable to their environment. They must constantly be protected from changes in temperature or pressure. But in a way, this fragility is the price to pay in order to be able to evolve. The strength of these systems also comes from their weakness. Because, by breaking easily and being very flexible, these huge molecules allow for experimenting with new forms. All it takes is for a few errors to slip into their story. These erasures might make it possible to obtain a new being. This is called evolution. One day, the extraordinary complexity of this mess will struggle to stay intact. Your atoms will dissociate, leaving behind a poorly ordered remnant of dead stars, which will certainly go on to participate in the construction of other things. Because within us, we have the basic building blocks to help create sumptuous perfumes. A big diamond, dozens of liters of a great wine, and a whole bunch of other less appealing things that we won't talk about here. When for us everything is said and done, for them, the atoms, the story will go on. Because these blocks seem to be immortal. No one knows how long one of them can survive, since no one has ever seen one die. They can transform by merging, but away from the conditions that exist at the heart of stars, they are almost imperishable. Which means that if atoms could talk, they would surely have a fantastic epic to tell. Let's use a water molecule as an example to illustrate this. The elements that compose it originate from distant spaces and times, regardless of your efforts to appear more youthful than your years. A large part of the elements that make you up is almost as old as the universe, and the other part is as old as the stars that formed them. Which means that even the youngest of them are older than our planet. Because the two hydrogen atoms in our water molecule were formed just a few minutes after the Big Bang. And to get here among us, they had to, for 13.8 billion years, stay far enough from the hearts of stars, which they probably passed through, so they wouldn't fuse there. As for the oxygen present in water, it was probably forged in the explosion of a massive star and is therefore as old as the star that created it. Obviously, no one knows if these three atoms stayed for millions or billions of years in the suns they passed through, or if they come from the same star. But what is certain is that after being expelled, all three of them eventually ended up one day, meeting and bonding in the cold of space. And since then, they've never been apart. Because water molecules, unlike those of our DNA, are extremely robust. And these two bonded atoms eventually settled on the surface of the Earth, thus contributing to the great water cycle. They've surely experienced thousands of clouds, drops, rivers, and shores, before perhaps finding themselves trapped in the ice pack for centuries, pulled from the ice by the force of the currents, tossed around in the body of a plankton, then integrated into the intestine of a fish and millions of other organisms, before evaporating for a while in the vein of an apple tree leaf, before being bitten into, eventually ending up contributing to the optic nerve of an eye connected to the brain of a human who wonders, what the hell is this mess? Before leaving it again, knowing that all of this is surely just a millionth of the story lived by these remnants of vanished stars. And the most extraordinary thing in all of this is maybe just that, having discovered that we, the living, are made of little pieces of stars that are not alive. Atoms whose existence we know, but who are unaware of ours. And over time, they ended up coming together to form something that we generally like to see remain structured this way, namely us, humans, capable of looking at the world, observing it, and partially understanding it. And it's still strange to think that without all those suns that are no longer there, well, we wouldn't be here.
And from that point of view, when someone looks at a star, isn't it a bit like the universe looking at itself?